Alright, this next section is pretty difficult, actually. I remember learning this for the first time, and I remember really struggling with it. So I'm gonna try to emphasize different things. It might end up being 2 videos instead of just one. Trying to emphasize what we're doing, why we're doing it. But what we're going to do now is why this whole K thing is useful, the equilibrium constant is useful, is because if I start out with a certain amount of my products and reactants, I can calculate how much I will have at the end. Okay, and doing that gets a little bit complicated, but that is the end goal, is we can, before we even run the reaction, we can see, okay, how much, after the reaction is done, how much stuff will I have of both my products and my reactants. That's where the power of this comes in. Okay, so keep that in mind, that that's what we're trying to do with this. And through all the twists and turns and everything, that is the ultimate goal. The first thing that we have to do is know if we're already at equilibrium, or if it's going to shift to the products, if it needs to make more products, or if it needs to make more reactants, if we've made too much product and we need to go back. So to do this, we are going to look at a value called Q. Now Q is the exact same thing as the K that we have been talking about. It is the concentration of your products over the concentration of your reactants. Alright, the difference is that it is not calculated to be the K. It is calculated from what you have. Alright, so what we did here is we found, with K, we found the equilibrium, right? And then we calculated this. So we knew what the constant was. With Q, it's whatever we are at. Okay, it isn't at the equilibrium point. It's at whatever we are at. So if Q does equal K, we are already at equilibrium. Nothing is going to happen to the concentrations. It's great. Okay, this is the awesome easy thing. Okay, if Q is greater than K, then I have too many reactants. Okay, and so my reaction is going to shift this way. So I'm going to end up with less reactants at the end when everything's all done, because that's what we're looking at. Q is where we are at, K is where we're going to, and when we get to K, I will have fewer products I will have fewer products and more reactants. Okay? If Q is less than K, then that is when I have too many reactants. And so I'm going to see a shift to my products. I will use up my reactants. I will make more product. So the first thing that we're going to do here is, with the information, they are going to give us K. We're not going to have to calculate K in these kind of examples. They're going to give us our initial amounts of everything, and we are going to calculate Q. And from that, we're going to say, okay, which way am I shifting here? Am I already set? Do I need more products, or do I need more reactants? So that is what the Q is. That's why we're using the Q, so that we can see which way we're going to go with the Q. Alright, once we know what way we're going to go, then we're going to use, it's called an ICE table. I-C-E. Okay, so it's an acronym. So the I stands for my initial concentration. What is the concentration at the Q that I'm talking about? Okay, the C is what is the change that is going to happen. And the E is the equilibrium, to get me to equilibrium. What will it be when I reach equilibrium? All right, and I need to add one word in here. This is the initial concentration of everything. All right, so now that we have this part set up, we know where we're going, we know what we're going to look for. Let's go back to the start of this section in the book, because they have a really awesome example there, page 591, about what we're trying to do. They've got that picture drawn, and they said, okay, we have this many of all these different things, and we need to find out where my equilibrium is going to be. And so they set up all the tables, and they found the right amount of everything. They did this by making a unknown, by making an X. They said, I know that I have 9 of my first molecule, and I know that I'm going to use some of that, so I'm going to subtract X. I don't know what X is, but I know I'm going to subtract it. Okay? I know that I have 12 of my other molecule, and I'm going to lose some of it too. Okay? I know I'm going to make, I don't have any of my first product, but I know I'm going to make some, and I know I don't have any of my last product, but I know I'm going to make some of it too. Okay? So this is what they set up, and this is what we're going to put into our table, this X thing, and that's where the Q comes back into it. So if we go back to my table here, I'm going to set up my initial, I'm going to calculate my Q. If it says that I need to get rid of reactants, then my initial reactants are, I'm going to put their concentration minus X, so I'll put their initial, and that will give me whatever their concentration is minus X. And this is what I put into my equilibrium equation now, so that I can solve for X when we get to there. What I mean by that is we had K is going to be equal to my products, C, D, over my reactants, A, B. Since we are looking for the change here, what we're going to see is instead of just writing C, we're going to go concentration of C plus some amount. Since it's going to be shifted, we're going to say it's shifting this direction. I'm going to have to add some amount there. Concentration of D plus some amount. Concentration of A minus some amount. Concentration of B minus some amount. And then I'm going to solve for X here. Okay, so this is, again, the thing that we are looking for. It isn't the equilibrium constant anymore. We already have the equilibrium constant. We're looking at how much the concentration is going to change in the end. Okay, and so that's why we're changing this up so that we can look at that. So what I'm going to do now is, hopefully at least your brain is starting to see, a couple of the concepts here. But let's go to a problem in the next. I'll do a separate video with the problem here, and then we'll work through a lot of these in class and try to make sure that this makes sense. All right. So the next section is just, I'm going to work through the problem on page 596, and then we'll work through a whole bunch of them in class.